In the forests of the American West, Hull Oaks Lumber Company still runs a sawmill steeped in the spirit of the steam age. Massive bandsaws, log carriages hauling tons of timber, and the skill of seasoned sawyers. Today, we follow the journey of a single log, from the landing yard to its final form as a structural timber. The journey begins in the log yard. Each log is scaled, its length, diameter, and volume estimated, while surface defects like checks, knots, and sweep are noted. Based on this, the sawyer decides the cutting pattern, ensuring maximum yield and proper dimensions for structural beams. The large logs are transported from large trucks to the river next to the factory. From here, the logs are dropped into the river and pushed onto large conveyor belts in preparation for the first stage of wood processing. The first preparation step protects the saw blade. Bark often carries grit and stones that dull the teeth. A debarker strips away the bark, while water jets wash off remaining debris. Now cleaned, the log is ready to be mounted on the carriage and sent to the head wheel, the primary saw. The log is locked in place with steel dogs. The sawyer chooses a reference base, deciding how to open the log for the best grain, avoiding splits and large knots. These early choices determine both recovery rates and structural quality. The head rig bandsaw makes the first opening cut. Its thin kerf reduces waste, saving valuable wood. Feed rate is carefully controlled, slower for harder, larger logs. The first slice produces a flat face. Successive cuts square the log into a usable camp. After each face is opened, the log is turned to create additional flat surfaces. The outer slabs containing bark and taper fall away to conveyors for fuel or byproducts. What remains is a squared camp, the rough core of the future timber. When required, the cant is resawn or run through a gang saw. Multiple blades divide the timber into uniform thickness. Blade spacing, conveyor speed, and log moisture are carefully controlled to minimize warping caused by internal stresses. Next comes the edging. Parallel saw blades trim the sides, removing wane and irregularity. Edge quality defines the board's grading, so this step ensures precise straight lines for structural use. Freshly cut or green lumber is sorted on the green chain. Workers grade by size and defects, stacking pieces into bins. Each board is stamped with a code indicating dimensions, lot number, and its next destination: kiln drying, air drying, or direct use.
These are what they call naturally aspirated fireboxes boilers, no force draft blowers. Okay, great. Thank you.
Moisture content determines dimensional stability. Boards are stacked with spacers, called stickers, to allow airflow and then loaded into the kiln. Drying schedules balance heat and humidity depending on species and thickness. The goal is equilibrium moisture, minimizing stress and surface checks. After drying, the lumber passes through a planer to reach its nominal size and a smooth finish. Sharp knives prevent tear out of the grain. Some timbers may retain a sawn finish, showcasing saw marks, depending on architectural design requirements. Every piece undergoes inspection for bow, crook, twist, checks, and knots. For structural timbers, strength and usable section are critical. Approved beams receive a grade stamp, certifying their load-bearing capacity to building codes. From raw log to finished timber, each step blends massive machinery with human expertise. At Hull Oaks, sawmilling is more than just cutting wood. It is the preservation of a technical heritage where every cut reflects knowledge of grain, material, and time itself. In the temperate forest, a Douglas fir nearly 60 feet tall, about 18.3 meters, is waiting to be processed. This is one of North America's iconic timber species, long grain with stable density and high strength, commonly used in timber frame houses and beam bridges. We follow the entire process, from site assessment, cutting plan, and safety setup, to topping, bucking, and gathering. Every action has a clear technical reason, from creating a wood hinge to control the direction of the fall, to using pulleys and load brakes to ensure the safety of the ground crew. When reaching the working position, the arborist secures an anchor line at a strong enough point, defines the fall radius, and establishes an escape route. The face cut angle on the fall side is usually between 45 and 70 degrees, combined with a slightly higher back cut to preserve the hinge. For this tree, the plan is to top it in sections, each piece tied with a rope, run through a pulley, and carefully lowered in a controlled manner. Once the top has been removed, the trunk is cut into transportable lengths. Remaining branches are cleared, and the logs are rolled to the staging area. Clean-cut surfaces help reduce end splitting. Sometimes, the arborist even seals the log ends to limit moisture loss. The kit includes a long bar chainsaw, static ropes, high-strength pulleys, friction devices, wooden wedges, and full protective equipment. Every saw is checked, chain tension, brake function, and bar oil before the work begins. The face cut determines direction. A clean 45 to 70 degree notch ensures the hinge will hold until the moment of release, guiding the tree exactly where it should go. The back cut is placed slightly higher than the notch, preserving the hinge. Once the fibers begin to compress, the ground crew tensions the line, and the top section breaks free under full control. The trunk is measured, chalked, and cut into lengths suited for hauling. Symmetrical cuts reduce pinching, keeping the bar free and the cut line straight. Branches are trimmed and cut faces kept clean. On Douglas fir, sealing the log ends can slow drying and reduce checking. From a 60-foot Douglas fir, the result is clean, useful timber for beams and boards. Every cut and every rope pull balance two priorities, safety and precision.